Good morning. As in the last classes, we discussed about the first unit. So now we will see the overall view of our first unit. Okay. So introduction to DSP. As we already discussed the definitions of signals and systems. A signal is a physical quantity that varies with time, space, and so on. Or we can define signal as it is a function of one or more independent variables, right? Okay, if it is varied with one variable, it is a single dimensional signal. And if it is varied with n number of signals, it is called n dimensional signal, right? So basically, signals are two types: continuous time signal, discrete time signal. Continuous time signal is nothing but it is continuous for all time of t, whereas the discrete time signal is we take a sample of continuous time signal and it can be frozen for some time and can be divided into equal intervals of time so that we will get the discrete time signal. So by the process of sampling, we can get the discrete time signal from the continuous time signal, right? Coming to the system is interconnection of the components. Okay, so here it will take input signal as a continuous time signal. It will give continuous time signal as the output for the continuous time system. For similarly for a discrete time system, uh, discrete input will be taken as the input and a discrete output will be given. So that is y of n equal to transformation of x of n for discrete time systems. For continuous time systems, y of t equal to transformation of x of t for continuous time sequence. Next, elementary discrete time sequences. So already discussed about the elementary discrete time sequences. That is, those are unit step sequence, unit ramp sequence, unit impulse sequence, exponential sequence, sinusoidal sequence, and a complex exponential sequence. Unit step sequence is it is 1 for n is greater than or equal to 0, otherwise it is 0. U of n equal to 1, so it is represented like this. Okay, and the unit ramp sequence is mm, mathematically represented as r of n equal to n for n is greater than or equal to 0, otherwise it is 0. So mathematical graphical representation is like this, and the unit impulse sequence is like this. That is delta of n equal to 1 for mm, n equal to 0. At n equal to 0 only, it is 1. Otherwise, for all values of 0, its value is 0. Okay, so it is represented like this. Next, exponential sequence is mathematically expressed as x of n equal to a power n for all values of n. So this exponential sequence can be dependent on the variable of a, that is if a is greater than 0, a greater than 1, or if it is in between the values of 0 and 1, or a is less than 0. Next, coming to the sinusoidal sequence. So its mathematical expression is a cos omega naught n plus phi. Omega naught is nothing but angular frequency, and phi is nothing but our phase angle. Okay, we can represent this sinusoidal sequence using Euler's uh, identity as x of n equal to a by 2 into e power j phi into e power j n omega naught plus a by 2 into e power minus j phi into e power minus j n omega naught. Next, coming to the complex exponential sequence. So it is in the form of a power n into e power j omega naught n plus phi. Or we can write this as a power n into cos omega naught n plus phi plus j sin omega naught n plus phi. So these are all the elementary discrete time sequences. Elementary discrete time sequences. Next, representation of discrete time signals. So how can we represent this discrete time signals? Graphical representation, functional representation, tabular representation, and sequence representation. So graphical representation means it is in the form of graph. Functional representation means it is like a function, that is x of n equal to minus 2 for n equal to 2, it is minus 1 for n equal to 1, 0 for n equal to 0, 1 for n equal to minus 1, and 2 for like that. Tabular representation, it is like table. So n values are given, x of n values are given. Sequence representation, it is like sequence set, that is x of n equal, for example, x of n equal to set of 1, 2, minus 1, minus 2, like that. Okay. Next, coming to the classification of discrete time signals. How these discrete time signals are classified. So these are classified like this: energy and power signals, periodic and aperiodic signals, symmetry and asymmetric signals, causal and non-causal signals. Energy and power signals. So energy is defined as sigma n equal to, as we already know that sigma n equal to n is minus infinity into mod x of n whole square. Similarly, power can be defined as limit n tends to infinity 1 by 2n plus 1 into sigma small n tends to minus n to n mod x of n whole square. So like this energy and periodic signal. Next, energy and power signals. Next, periodic and aperiodic signal. Periodic means it is which satisfies that condition x of n equal to x of n plus n. Okay. Otherwise, it is not periodic. It is represented like this. Next, symmetric and asymmetric. Symmetric means it's mirror image is equal to the original image. Symmetric signal are it is said to be symmetric or even symmetry are said to be it satisfies the even symmetry condition or even signal, that is x of n equal to x of minus n. A cos omega n is even signal. Odd signal means x of n equal to minus of x of minus n. Okay, that is odd signal. Okay, so and the discrete time signal x of n can be represented as sum of even signal and odd signals. So that is xe of n and xo of n. Okay, so in the above expression, replace minus n, replace n by minus n, then it will become x of minus n is equal to xe of minus n plus x naught xo of minus n. So according to the definition, x of minus n equal to xe of minus n is nothing but xe of n, and the xo of minus n is nothing but xo of n. So xo of minus n, xo of odd function xo of minus n is nothing but minus of x of n. So that it will become x of minus n is equal to xe of n minus xo of n. So by combining these two, x of n and x of minus n, we will get x of n plus x of minus n equal to 2 into xe of n. That is xe of n is addition of these two by the average of these two. So that is x of n plus x of minus n by 2. Similarly, by subtracting x of minus n from n, we will get the expression for xo of n. So xo of n equal to x of n minus x of minus n by 2. Like this, these are the periodic and aperiodic signals. And next one is symmetry and asymmetric signals. Next one is causal and non-causal. Causal means its value is 0 for n is less than 0. A signal is said to be causal signal if its value is 0 for n is less than 0. Otherwise, the signal is said to be non-causal system. It means that its value is greater than or equal to 0. The causal signal is defined as x of n equal to a of n, a power n into u of n, and non-causal system x of n is equal to a power n into u of minus n plus 1. So next, coming to the classification of discrete time systems. So above one is a classification of discrete time signals, that is a periodic, aperiodic, symmetric, asymmetric, causal, non-causal. Okay, causal, non-causal, and mm, uh, energy and power signals. In the same manner, we have the classification of discrete time systems also. So these are classified into static and dynamic systems, causal and non-causal systems, linear and non-linear systems, time invariant and time variant systems, FIR and IIR systems, stable and unstable systems. Okay, static and dynamic system. What do you mean by static system? A system is said to be static if its output at any instant of time depends on the input samples at the same time, but not on the past and future samples. Present depends upon the present state of the input. Okay, so for example, y of n equal to a into x of n. This is the static system. They suppose if you take the dynamic system, it depends upon the past and future values. Okay, that is y of n equal to a into x of n minus 1 plus x of n plus like that. Next, causal and non-causal systems. Causal system means the output of the system at any time depends at present and past inputs. Present and past inputs. That is x of n. Okay, x of n minus 1, x of n minus 2. So present and past inputs. Okay. So if it depends upon the future inputs, then we can say that it is a non-causal system. Then linear and non-linear system. Linear system means it obeys the superposition theorem and homogeneity principle. Then the system is said to be linear system. For example, transformation of A into x1 of n plus b into x2 of n will become A into transformation of x1 of n plus b into transformation of x2 of n, where A and b are called arbitrary constants. So this is linear system. If it doesn't satisfy this condition, then we can say that it is a non-linear system. Next, time invariant and time variant systems. Time invariant means it doesn't depend upon the time. Okay, so we have the time invariant system. uh, For a time invariant system, if y of n is the response of the system to the input x of n, then response of the system to the input x of n minus k is also y of n minus k. It means that it completely depends upon the time. So that is called time variant system. If, if it doesn't depend upon the time, then that is called time invariant system. So y of n minus k equal to transformation of x of n minus k. P is nothing but time variant system. If y of n minus k is not equal to transformation of x of n minus k, then the system is said to be time invariant. Next, FIR and IAR systems. If the impulse response of the system of the finite duration, then the system is said to be a FIR system. That is, h of n equal to 1 for n is minus 1, it is 2 for n equal to 0, it is 3 for n equal to 1. That is the FIR system. Okay. A system has impulse response of infinite duration. So for finite duration it is called a FIR system. For infinite duration it is called IAR system. That is h of n equal to a power n into u power u of n. And stable and unstable systems. The system is said to be stable if it produces a bounded output sequence for the bounded input signal. One bounded input signal x of n and the output is unbounded, the system is called unstable. Okay, it means that you have to satisfy the condition sigma n equal to minus infinity to infinity mod h of n must be less than infinity in the sense, but it must be some finite value. It should not some. It should not infinite value. It must be some finite value. Okay. So it has to satisfy the condition sigma n equal to minus infinity to infinity. Mod h of n must be less than infinity. Okay. After that, we have done some problems also, simple problems. So test for stability and stability of the system. Okay, like this stability system. We have checked the stability system. Causal, non-causal systems, time variant, time invariant systems. Okay, periodic, aperiodic signals. Okay, and then coming to the invertibility or inverse system. Okay, invertibility or inverse system. The system is said to be invertible. We can generate the input signal x of n from the output of a system by n. Okay, can generate the signal x of n from the output of the signal y of n. It can be generated by using cascading of the inverse system with the original system. A system is there h of n, that is the original system. It can be cascaded with the inverse system h inverse of n. Okay, so the output of the original system is y of n, which is nothing but the input of the inverse system, and it will produce the output to omega of n, w of n. Okay, so w of n can be obtained by using the convolution of the original system with the inverse system. Okay, so what is the original system? X of n convolved with h of n, whole convolved with h inverse of n. So x of n convolved with h of n convolved with h inverse of n. H of n convolved with h inverse of n will become on. So it is x of n. So invertibility. Invertibility means you will get the original signal or inverse system. You get the original signal. Omega of n is nothing but x of n. Next we will see the we saw the convolution of the two sequences. Okay, we have done two problems on this one. Okay. Next convolution. Convolution is nothing but a x of n convoluted with h of n, so that we get y of n. Y of n, it is mathematically represented as y of n equals sigma a k equal minus infinity infinity x of k into h of n minus k, or it can be represented as y of n equal to x of n convoluted with h of n. Okay, star represents the convolution operation. Okay, so and these are the various steps involved in doing the convolution. Okay, next properties of convolution we observed, that is commutative law, associative law, and distributive law. After that, we will see the convolution of two sequences also. Now, I have done a problem. Next, coming to the jet transform. Jet transform is defined as x of z equals sigma n is minus infinity infinity x of n into z power minus n. We may have one-sided jet transform or two-sided jet transform. Okay, if it is varying from 0 to infinity, then we can say that it is unshaded. Unshaded. If it is varying from minus infinity to uh, minus infinity to infinity, then we can say that it is double shaded jet transform. Okay, so by taking the radius equal to 1, okay, so to radius is 1, then that is replaced complex variable which is replaced by r into e power j omega. R is the radius of the circle. If r is 1, then it is nothing but our Fourier transform. Okay, so like this we have this is the jet transform, and we have a region of convergence. So what is meant by region of convergence? What is meant by region of convergence? The set of all values of z for which x of z gets finite value is called region of convergence. Okay. And then we have right-sided sequence, right-hand sequence, left-hand sequence, and both two-sided sequences of the jet transforms are available. Okay. So next, already discussed about the properties of ROC. Okay, we have some properties, 70 properties of ROC are there. Next already next we discussed about the properties of jet transform. Okay, linearity property, time shifting property, time scaling property, time reversal property, okay, differentiation property, integration property, convolution property. All these were discussed in our class, in earlier classes, initial value theorem and final value theorem. Okay, right. So these are all the this is about the jet transforms. This is about the jet transform. This is about the jet transform. Then we discussed about the system function. System function means is nothing but the ratio of output to the input. In the coming to the system function. Okay, system function in general system function is defined as the output by input. So, but here we discussed about the system as a linear constant coefficient differential equation of the form, that is sigma k equal to 0 to n a k into y of n minus k is equal to sigma k equal to 0 to m b k into x of n minus k. Okay, we can write this as a naught into yn plus sigma k equal to 1 to n a k into y of n minus k is equal to sigma k equal to 0 to n b k into x of n minus k. Okay, so put a naught equal to 1, then it will become y of n plus sigma k equal to 1 to n ak into y of n minus k is equal to sigma k equal to 0 to n dk into x of n minus k, or y of n equal to sigma minus sigma k equal to 1 to n ak into y of n minus k plus k equal to 0 to n dk into x of n minus k. So taking that transform on both sides and applying shifting property, get y of z equal to minus sigma k equal to 1 to n ak into y of z into z power minus k plus k equal to 0 to n dk into x of z into z power minus k, or y of z taking as common 1 plus sigma k equal to 1 to n ak into z power minus k is equal to sigma k equal to 0 to n dk into x of z into z power minus k, or taking the ratio of y of z to the x of z, y of z by x of z is equal to sigma k equal to 0 to m dk into z power minus k by 1 plus sigma k equal to 0 to 1 to n ak into z power minus k. So y of z by h of z is nothing but x of z is nothing but h of z. So it is equal to sigma k equal to 0 to n dk into z power minus k by 1 plus k sigma k equal to 1 to n ak into z power minus k. This is nothing but the system function. H of z is nothing but the system function. Okay, or it is also called as transfer function also. Transfer function or system function. Okay. So after that have done some problems related to system function or transfer function. Okay, these are all the problems. Next, time response analysis of the discrete time systems. Okay, so it can be written as that is a difference equation. It is in the form of difference equation, that is sigma k equal to 0 to n a k into y of n minus k equal to sigma k equal to 0 to m b k into x of n minus k. Okay, if the quotient a naught is not equal to 1, then the solution of the differential equation can be expressed as sum of two parts, that is y h of n plus y p of n, homogeneous, that is sum of the homogeneous solution and particular solution. Y of n equal to y h of n plus y p of n, homogeneous solution plus particular solution. So next, coming to natural response or zero input response. Okay, for discussing the natural response, here we have to equate the solution of the above differential equation with the x of n equal to 0. X of n must be equated to 0. So for the discrete time system, the natural response is the solution of homogeneous solution, that is sigma k equal to 0 to n a k into y of n minus k is equal to 0. Why? Because x of n is 0, that's why this is equated to 0. Sigma k equal to 0 to n a k into y of n minus k, which is equated to 0. The solution of this equation is of the form y h of n is equal to lambda power n. Okay, so substitute these values in the above equation, we get sigma k equal to 0 to n a k into y of n minus k is replaced by lambda power n minus k. Okay, so we can write this as a naught into lambda power n plus a1 into lambda power n minus 1 plus a2 into lambda power n minus 2 plus dash 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 up to an into lambda power n minus n is equal to 0. So let a naught is 0, then put lambda power n minus n as common. So it will become lambda power n plus a1 into lambda power n minus 1 plus dash 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 an minus 1 into lambda plus an is equal to 0, or this entire expression will become 0. It is nothing but the characteristic equation. We will find the roots for this characteristic equation as lambda minus lambda 1 into lambda minus lambda 2 up to lambda minus lambda n, which is equated to 0, so that we will get the roots lambda 1, lambda 2, lambda 3. These are also called as eigenvalues of the system. Roots are eigenvalues of the system. So the nature of the roots will be real, imaginary, or complex roots. So if the roots lambda 1, lambda 2 up to lambda n are distinct, in that case, the general solution of the homogeneous equation is y h of n equal to c1 into lambda 1 power n plus c2 into lambda 2 power n plus c3 into lambda 3 power n up to cn into lambda n power n, where C1, C2, C3, and Cn are, these are all arbitrary constants. So if the roots are repeated, that means that these two are equal. The roots are lambda 1 is minus 2, lambda 2 is minus 2, and lambda 3 is 2. Then the solution will be like this: yh of n equals C1 plus C2 into n whole into lambda 1 power n plus C3 into lambda 3 power n. Okay, so that is the solution if the two roots are equal and another root is different. If the roots are complex, that is lambda 1 equal to a plus ib and lambda 2 is a minus ib, then the solution will be yh of n equal to r into a1 cos omega theta plus a2 sin omega theta, where r is nothing but square root of a square plus b square, here a and b are constants, and theta is a tan inverse of b by a. Okay, so like this we can solve some problems also. Okay. Mm, and then we discussed about these are all problems. We discussed about the forced response. We discussed about the forced response. What is meant by forced response? It is obtained by summing the particular solution as well as a homogeneous solution. Particular solution as well as homogeneous solution, and finding the quotients of the homogeneous solution so that the combined response yh of n plus yp of n satisfies the zero initial conditions. Zero initial conditions. After that, we see some we have some input signals. These are all input signals, and particular solution for these input signals is like this. So, and we have done some problems also on this forced response. Like this, we will do some problems. We have done some problems. After that. After that, we discussed about the frequency response. Okay, frequency response analysis of the discrete time systems. So here the frequency response analysis of the discrete time systems, the y(n) of any linear time invariant system to an input signal x of n can be obtained by using the convolution sum, that is y of n equal to sigma k equal to minus infinity to infinity h of k into x of n minus k. Okay, so h of n is nothing but impulse response of the system. So complex here we consider the complex exponential signal, that is the input, that is x of n equal to e power j omega n as input for the system. So by substituting this input signal in this expression, so that this expression will become y of n equal to sigma k equal to minus infinity infinity h of k into e power j omega n minus k. So x of n minus k is replaced by e power j omega n minus y because it is complex exponential signal. So it is equal to sigma k is minus infinity infinity h of k into e power j omega n into e power minus j omega k. So e power j omega n can be extracted out into sigma k is minus infinity infinity h of k into e power minus j omega k. So e power j omega n into this is nothing but h of e power j omega. This capital H of e power j omega is nothing but sigma k equal minus infinity infinity h of k into e power minus j omega k is nothing but our frequency response. Is the quantity h of e power j omega is called frequency response of the system. So the frequency response is a complex varied function and it can be expressed in polar form. So it can be, for convenience, it can be expressed in polar form, that is h of e power j omega is equal to, it is in the form of magnitude and phase angle form, that is mod h of e power j omega into e power j omega theta. Here mod h of e power j omega is called magnitude response, and theta of omega is called the phase response of the system. So here the magnitude response is even function of omega, that is mod h of e power j omega is equal to h of e power minus j omega mod h of e power j omega. Why? Because it is even function. Okay. Similarly, this theta of omega is a phase response. Phase response system is an odd function of omega. That's why you can represent this as theta of omega equal to theta of minus theta of minus omega. Okay. So this is about the frequency response of the discrete and system. Okay, with this, I'm concluding the today's class. Tomorrow we'll continue. Okay, thank you.